So we are finding the zeros and stating the multiplicity. So to find the zeros, we are going to do what? Factor. We're going to factor out an x, negative x squared. Remember, we should always keep our leading term in this quadratic a positive. Then can I factor the quadratic? Yes. What does that factor to? X minus 3, x minus 3. So we can do x minus 3 squared. Right? All right. So those are our factors. What are our zeros? So we get x equals 0 from the first factor. What's the multiplicity? 2. And we get x equals 3 from the second factor, and the multiplicity is 2. So when I go to graph these and I have a second multiplicity, is that a cut, a bounce, or a jog? It's a bounce. So keep that in mind. We have 2 bounces. What's the maximum number of turning points? Well, what's the degree? So it's a degree 4. So they are just saying possible. How many possible turning points do we have? 3, okay? So they're not saying that's actually going to happen, and it may or may not. Use the leading term to test the end behavior. So our leading term is negative x to the 4th. So we are going down both ways. And we could write that as limits if we wanted, but right now we're just going to buzz through. What's the y-intercept? Go back to general form. What's the y-intercept? 0. We are going to go ahead and do the test points, because yesterday we didn't. So we have a factor that gave us the zeros and a 3. And I'm going to write this over here in factored form. Now, this is a little unique, a little different. If I put in, for instance, a negative 1, understand this negative out front is a negative, separate from our factors. If I put any number in here at x squared, isn't it going to square to a positive? If I put any number into this parenthesis, it's going to square to a positive. No matter what, whether the numbers, the test points are negative or positive, we're going to get this situation, right? So this front negative times a positive is always going to be negative. So I really don't have to pick numbers. We can see that, yes? So we're never going to go up into the positive regions above the x-axis. Kind of weird. So let's see what this looks like. We are at 0 and 3 for the x-intercept, and we're at 0 for the y-intercept. We know from our end behavior that we're going to start low and end low. So we're going to come up. We're going to bounce, come back, bounce. It's an M. Okay? Easy enough. We can do that. Everyone's comfortable. Today, are you ready? Are you excited? We're going to do dividing polynomials. So excited. Dividing polynomials. Okay, so we're going to learn about the division algorithm first. The division algorithm, you knew as a little kid, you may not have known it was a division algorithm. But let's go to the side here real quick before we get too crazy. When I went to divide that when I was little, what would you say? 4 goes into 23 5 times with a remainder of 3. And your teacher made you check your work, and she said it's 4 times 5 plus whatever you had left should equal what you started with, right? That's the division algorithm. If you take your divisor and multiply it to your quotient, that answer, then add your leftover remainder, you should equal the dividend, okay? What you're dividing into. So that's this division algorithm. When I was little, my remainder always had to be smaller than my divisor. That's why I knew I was done when I couldn't divide anymore. In polynomial division, your remainder's degree has to be smaller than your divisor's degree. So it's no longer looking at numbers. I can divide numbers, bigger numbers into little numbers now. We can have fractions in our polynomial. But you can't divide a bigger degree into a smaller degree. Okay? So we are going to pop back into 3rd grade here. Are you ready for time work? We're going to divide 7 into 1,965. So again, when we were younger, we did not just divide that all at once. You did little steps. So we said 7 goes into 1, it can't. So we go 7 goes into 19 twice. Then what did you do? You put a 14 here because we multiplied to the front. And then what did we do? Subtracted, and we got a 5. Then what did we do? Drop the 6 down, good. And then we divide it again. 7 goes into 56 8 times, and we multiply out front, put the number down there, and we subtract, and we drop down our next term. 7 goes into 5 0 times. And we multiply out front, and we subtract. We have no more terms to drop down. That's going to be our remainder because it's smaller than 7. Okay? Easy enough. We're going to do the same steps in polynomial division. So, here we go. Things to know. Things to make sure you do. When you write the divisor and the dividend, you need to make sure they are in standard form. So that means you start with the leading coefficient and you decrease your exponents. If you're missing an exponent, so I'm going to start with x to the 5th here. I don't have an x to the 4th, so I need to put a 0 term in to hold the place. If not, it gets really ugly. So any exponent that you are missing, any term, like we don't have an x term, so I'm going to put a 0 there. You have to have placeholders. So that's the first thing you need to double check to make sure you're good with. All right, so everyone got it written down and ready to go? So again, we're not going to do the whole big shebang in one step. We only care about the first term, the leading term, going into the leading term. Sometimes it's easier to think of multiplication. What can I multiply x squared by to get x to the 5th? X to the 3rd, right? I'm putting 1s with it just because they have zeros and I don't want to get mixed up. So then we have to multiply to the guy out here. Not to just the first guy, but all 3 guys. That's how these 2 terms get into the game here. So we're going to multiply x cubed by all of these. Right, so all 3 of them, you're distributing it to the outside divisor. Then what do? We subtract. So it's easier for me, it's up to you, but it's easier for me if I'm going to subtract this to go ahead and distribute my subtraction sign, and then I can just add. That way I don't forget to subtract any of them. If you distribute the subtraction sign and just change all the signs there on that second line, you're ready to go. The first term should always cancel. You are making it so it will cancel. 0 plus 1 is 1x to the 4th. 4 minus 1 is 3x to the 3rd. And then you drop down your next term. And then you just repeat the process. X squared goes into x to the 4th. What do you want to multiply x squared by to get x to the 4th? X to the 3rd, or x to the 2nd. Right? And you multiply to the guy out front. Draw your line. Go through and subtract, distribute your subtraction, and add your lines together. So go ahead and finish this one. Okay, did we get a remainder of x plus 2? All right, so they're not hard, they're just, you gotta keep things nice and neat and make sure you can see where your positives and negatives are. Okay, all right. Do you want to see another example, or do you think you're good? Good? Sure? You have one keyed up. We're good? All right. Synthetic division. Remember this from last year? This is the easy, quick one. You can only do synthetic division when your divisor is linear, meaning you're dividing by something to the power of 1. So that previous one, we had an x squared out front. We can't divide synthetically with those. So just when your divisor is linear. So you have to take your divisor, set it equal to 0, and solve. So we're going to get x equals -3. That's what goes into the box. Then you're going to write your coefficients. Same thing as with long division. If you're missing a power, you need to put a 0 in there. So I don't have a cubic term. So put a 0 in there. So write your coefficients down, and then you're ready to go. And again, this is the easiest thing ever. You drop down that first coefficient, he goes in your answer box, or blank, and then you multiply to the box, and you add, and then you multiply to the box, and you add, and you multiply to the box, and you add, and you multiply to the box, and you add. Now I separate that last guy because he is our remainder. The last term is always your remainder. Now we need to write the rest of this as a polynomial. If I had a 4th degree and I divided it by a 1st degree, what's my answer going to be? Degree 3, right? It's going to be a cubic. So we're just going to write this, and it's in standard form already. These are the coefficients. So that's my quotient, and this is my remainder. Some of you last year, they just asked you to divide, and you might have put the remainder at the end of your answer and made this one big, long answer like that, and that's fine. Most of the time we're going to say, what's the quotient, what's the remainder? Okay? So that's not wrong to do, but they might just ask you quotient or remainder. Very good. You remember synthetic division? It's fairly easy. Do you want to see another example of that? We're going to do one within another one, but do we need another plain old synthetic guy? Okay. So, remainder theorem. Basically, if you take your box number and you plug it into the original function you're dividing into, whatever your answer you get out is going to be the remainder. So I'm just going to pop back to this one here. If I wanted to know the remainder without dividing, I would pop in -2, because my box number would be -2. So if I put -2 in here, and I put that in my calculator, I get -22. So the remainder, if I did synthetic division, would be -22. Okay? It's a quick way to check your synthetic division, 1. And 2, why do you think we would care about the remainder? All right? So why is it important? Because of the factor theorem. How do you know that 4 is a factor of 20? How do you know 4 is a factor of 20? 4 goes into 20 5 times with a remainder of 0. So when something divides in evenly, it's considered a factor. So if I get a factor and I set it equal to 0 and I find that box number and I plug it in and I see a remainder of 0, that tells me this guy is actually a factor of the polynomial that I'm dividing into. So that's an important thing. Okay? So, tell me which, if any, of these are factors. Find the remainders, and we'll kind of buzz through them because it's Friday. What am I going to plug into this guy? 2. If I put 2 into that function, I get 6. Is that a factor? No, my remainder is 6, not 0. Here I'm going to put in what? -1. Here I get -24. Is x plus 1 a factor? No. I mean, I'm just guessing because I'm doing an example that this has got to equal 0, right? That equals 0, which means x plus 4 is a factor. Easy enough? So this is a quick way to tell, without doing long division or synthetic division, if something is a factor. The remainder has to be 0. Now, how can that be helpful to us? Well, let's say we are given that 2 is a 0. If 2 is a 0, that means if I plug 2 in, I get a 0. What is a factor? What would the factor be that matches that 0? X minus 2. Right? Okay. So I know one factor. There's no rule for factoring cubes, unless it's a difference of cubes or a sum of cubes. There's no special rule. I couldn't factor that, and I've been teaching math like forever, right? So you have to, in order to factor something like that, have a starting spot. Be given something to start with. So we know that 2 is a 0. They gave me a hint. So I know x minus 2 is a factor. This is a cubic. If I divide by a power of 1, it would drop down to a quadratic, right? Can I factor quadratics? Yeah, we can all work with quadratics. We know those rules. So we're going to take this 0, and we're going to use it with synthetic division. And you're going to do that synthetic division very quickly for me. Go, go, go. I'm going to pause. Okay, did everyone get that with synthetic? So we have this quadratic that we need to factor. We know the first guy is 3x and x. The last term has to be made up of a 1 and a 3. My outside is 9. My inside terms multiply to 1. If I subtract those, I get 8. So that's my factor. Keep in mind, I still have this factor. Right? So there's all 3 of my factors. It's a cubic. It will have 3 factors. And then I can set each of these factors equal to 0. We know this one's already a 2. What does this guy give me when I set the middle guy equal to 0? 1/3. Good. And the last guy is going to be -3. There's my zeros. So in order to solve or factor a bigger polynomial, we're going to have starting spots. And today we're giving them to you. Tomorrow, not tomorrow, Monday, we're going to think of another way to figure out where the starting spots without being given it. All right? And then we can do division. Basics.